Welcome to this lesson on function rules. Please make sure you have these notes in front of you so we can begin our lesson. The learning objective for this lesson says I can create a function rule for a sequence of numbers. So let's go ahead and talk about some of the vocabulary. The first vocabulary word is function. And a function is a relation that assigns one output value to one input value. The second vocabulary word is called a function rule. And a function rule is something that describes the relationship between the input and the output value. So let's go ahead and talk about some basic rules. If I have 3 plus 3 plus 3, that's repeated addition. But another way that I could write that would be equal to 3 times 3. I could also write 2 plus 2 plus 2 plus 2 as repeated addition. But a shortcut would be to take 2 and to multiply it by 4 because I'm adding it 4 times. So we can use this concept to go ahead and describe a relationship between our output values. Another example would be x plus x, which would be the same thing as 2x, or 2 times x. So the next vocabulary word is called sequence. And a sequence is a list of numbers in a specific order. The last vocabulary word is called arithmetic sequence. And this kind of sequence is found by adding the same number to the previous term. So say for example I have 5 my first term, 10 my second term, 15 my third term, and 20 my fourth term. I can continue that arithmetic sequence because every time I move to a new term, I'm adding 5. So each time I add to a new term, I get 5. So we can predict what the next one would be. If I add 5 to 20, my next term would be 25. So the key concepts for today would be us discussing how to find a rule. A sequence can be shown in a table. A table gives both positions at each time in the list and the value of the term. So what that means is if I'm given a list of numbers like 8, 16, 24, and 32 and so on, that's a list of numbers, or that's an arithmetic sequence of numbers, because every time I move to another term I'm adding 8. So I can go ahead and place these sequence of numbers in a table. The first day I would have $8 in my bank account. So in the first position I have $8. The second day I have $16. The third position, or the third day, I have $24, and the fourth position, or the fourth day, I would have $32. So all I did was I organized my sequence, or my arithmetic sequence of numbers, and I put them in a table. The position would be my x position, and the value of the term would be the y. The position would be my independent variable, and the value of term would be my dependent variable. So this is my independent variable, and this is my dependent variable. So let's use these key concepts to discuss the following examples. For example 1, it says describe the relationship between the terms in the arithmetic sequence 7, 14, 21, 28, and so on. Then write the next 3 terms. So we know that this is a sequence because there's a specific order to these numbers. So if I go from 7 to 14, I'm adding 7. If I go to 14 to 21, I'm adding another 7. If I go to 21 to 28, I'm adding another 7. So my rule is let's keep adding 7 to the previous numbers. Or I could say the relationship is found by adding 7 to the previous term. So let's figure out what the next 3 terms are in this sequence. If I take the last term, which was 28, and add 7, I get 35. If I take 35 and add 7 to 35, my next term would be 42. And if I take 42 and add 7 to that, it would be 49. So 35, 42, and 49 are the next 3 numbers in this sequence. So pause the video and complete these Got It problems, and we'll discuss the answers in class tomorrow. Notice I have 2 Got It problems on this page, Got It problem A and Got It problem B. For example 2, it says create a function table for the sequence of numbers 3, 6, 9, 12, and so on. So let's go ahead and place these numbers from the arithmetic sequence into the table. On the first day, or my first position, I have $3. On the second day, or my second position, I have $6. On the third day, I have $9. And on the fourth day, I have $12. Notice the next column, we have a value of n. So they're not necessarily placing the number 5 in there. It could be any number in the world. It could be the 20th position. It could be the 100th position. So it could be any number in the world. It doesn't have to be 5. So let's look for patterns here. To get from 3 to 6, I would add 3. And I would add another 3 to 6 to get 9. And then I would add another 3 to 9 to get 12. So basically I have a pattern here of continuing to add 3, or repeated addition. A shortcut to repeated addition is to just multiply by 3. So what this means is I'm going to take my independent variable, which is the position. I'm going to take those numbers and plug it into a function machine. And the function machine says you're going to multiply it by 3. So if I take 1, which is my first position, and I plug it into the function machine and I times it by 3, I get 3, which is my output value. Notice I have 3 in the value of term for the first position. Let's take the second position, plug that into the function machine by multiplying it by 3, and 2 times 3 gets me 6. Notice that is the second value of term for the second position. Let's take the next position, plug it into the function machine by multiplying it by 3. 3 times 3 gets me 9. Notice that is the next value of term. And then let's go ahead and take 4, plug that into the machine, times it by 3, and I would get 12, and that is the next value of term. So we can continue this process, but what happens if I want to know the nth term, or an unknown term? What I could do is I can take n, put it into the machine, and multiply it by 3. And that will give you your value of term. So that's the rule right there. We can take 3 and multiply it by n, and that will give us the value of term. 3 times an unknown number will get us that number. So look at the next part. It says, what is the value of the 10th position? Well, you can continue building this table until you get a really large table, or you can make your life easier and use the function rule that we came up with. Since I know the function rule is to take the position and plug it into the function machine, I'm going to take the position, which is 10, and multiply it by 3. So the value of term for the 10th position is 30. So using the rule is a shortcut to figuring out what the value of term for any position. So pause the video and complete these got it problems, and we'll discuss the answer in class tomorrow. Notice this has only one got it problem, but there's different parts to got it problem C. So for example 3, it says create a function table for the sequence of numbers 17, 20, 23, 26, and so on. So according to this table, they're telling us that 17 is the 5th position of the sequence. So the 6th position will be 20. And the 7th position will be 23. And the 8th position will be 26. In the last box, they're giving us the value of n. So that doesn't have to be the 9th position. That could be the 20th position, or the 40th position, or the 100th position. It could be any number in the world. So let's go ahead and take a look at our pattern. To get from 17 to 20, I can add 3. To get from 20 to 23, add another 3. From 23 to 26, add another 3. So this is an example of an arithmetic sequence, because every time I move to a new position, the value of term is added by 3. So we know this is repeated addition, but a shortcut to repeated addition is to multiply. So I can multiply the position number by 3. So that would be my first thing to do inside of the machine, just multiply it by 3. If I take the position number, which is the input, plug it into the machine, I should get my value of term, or my output. So let's take the 5th position and plug it into the machine. 5 times 3 gets me 15. But notice I don't have 17, which is the value of term that I need to have. So what I have to do is I have to send it into the function machine, and I need to add 2 to it to get 17. So after I do that, then my dependent variable comes out of the machine to get the value of term. So let's try that rule again. Let's take the 6th position and place that into the machine. So 6 times 3 gets me 18. But it's still in the function machine and it has to add 2 to it. So now 18 plus 2 gets me 20. Notice that's the value of term that I have. Let's take the next position, which is 7, place it into the function machine. So 7 times 3 gets 21. But it has to continue to go inside of the function machine by adding 2, and I get 23. So I've got 23 here. Let's go ahead and take our next position number, which is 8, place it into the machine. So 8 times 3 is 24. So it's going to continue on in the function machine. So let's add 2, and we have 26. That's the next value of term. So according to the table, n is the next position. What I can do is I can place n, which could be any number in the world. So n inside of the machine, I'm going to multiply n by 3, and I get 3n. It has to continue on in the machine, so I need to add 2, and that will get me my next value. So what I've done right now is I've just created the rule. The rule for this function table is we need to take 3 and multiply it by the position, which we don't know, and then add 2 to it. So this equation will help make my function table true. So for the next part, it says, what is the value of term for the 10th position? So we could continue this table up to the 10th position. But I'm going to use the function rule that we've created to figure this out. So I'm going to take 3, multiply it by 10, which is the position number, and then add 2. So 3 times 10 is 30 plus 2. So my value of term for the 10th position is 32. So pause the video and complete this got it problem, and we'll discuss the answer in class tomorrow. Notice there is only one got it problem on this slide, but got it problem D has multiple questions. So make sure you're answering all the questions for this slide. So we've just completed this lesson. Go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.